So this is what we have today. Topic is combiner. We're using the concept of combiner and how it works. So combiners say what? Right, so defs.local data by default the path of this is the mapper output, right? So it is recommended mapper output should be stored on LFS. How you set the path? You want to put an SDFS, LFS or cache memory or somewhere. This is the parameter defs.local.dir. You have to set this path onto that and it will start working. Now, the questions come here. By default is what? TMP directory. By default is what? TMP directory. You can put on the cache memory as well if you have sufficient storage cache and it will work much faster. Okay. So this is how we write the path. Now, what we have, if this is the batch, this is the job is running, so how we can go through. So in that condition, I will ask you to use the combiner. Combiner is what? Again, it's come from the performance tuning. Understand first the combiner. I'm writing the case for. Okay. So this is what. Let's see. You have some data. Okay. Just understand. You have some data. Okay. Let's say BJP. Right. Word count or EVM machine, electronic voting machine. How it will calculate BJP. You have BJP. You have TTP. Or again the BJP. And some votes we have like, right, RJT, right. Some of the data we have, and among this we have already discussed what EVM how it works. So like in this different parties, like say we have one GB of data of the vote, the vote cast by the voter, and that is what size of this we have to count what, how many votes that. So this is what I was talking about, right, sir? This is what I was talking. Let's say we have in the data. Suppose BJP is coming multiple times, right, sir? Right. This is what data we have, in which BJP is coming. What? 10 million record. 10 million, right? That votes across to BJP. Right? And this 10 million record has to given the result by whom? Reducer. So how we run the job and back in how the map reduce will process. We have already talked about the alpha, right? So suppose this is the this much record that BJP, right? And for this much record, BJP word will occur this number of times, right? So what do you have in this? This is what this is what how it will pass to the input to the mapper, and mapper will give you the output in which format? BJP one, right, sir? It will give you the result like this, right? Right. Hope you understand. Yeah. This is how the output will come BJP one, right? How many times it will occur? 1 lakh, so it's not 10,000. Right. Right. 1 lakh records, BGP 1 BGP. So let's say this data size what? This data size maybe, for example, let's say this data size what? 1 GB. This number of it's a 1 GB we have. This 1 GB data which is stored where onto LFS, right, sir? And this output, mapper output is stored where? Onto LFS, right, sir? This is a parameter. So this output we have to pass to whom? Reducer, right? I believe it is going through recording. All right, thank you. So this output will pass to whom? Reducer as an input. Who will perform this job? It's a task tracker, right? It will what? Task tracker. Move the data from LFS and pass to the reducer as a input, right, sir? That we understand. So now what you have, it will take time. Laptop, you have moved the data 1 GB, take time, right? According to the size of the data, it will take time, right? So let's say it takes time. It takes what? T1 time, okay? T1 time to move the data from LFS to reducer. Reducer will process how? It will put the iterator. Remember the mapper is program. Iterator will put. So how the output will be given to the reducer? Right, sir? It will so on, right? How many times it will return? Right? So this, how many times the iterator will call? 1 lakh times. So let's see. When the iterator will call, it will take T2 time. So to keep the result, to give what? BJP, total records what? 1, 2, 3, 4, 5. Okay. How much time it takes? T times. Right, sir? Understand? T times. Objective is what? That is what called performance tuning. Performance tuning that is being performed by developer. So you being a developer, you will be expected give me this kind of tuning. Alright. So being a developer, I will say tuning means what? Reduce the access time. The time it is taking time is taking 10 minutes, you have to give the result into 5 to 6 minutes or just give the best performance by reducing the time access. So see how we can achieve this. This output will pass to whom? This is what time taken and this output will be given to the reducer here, right? Output, right? Right, sir? This is what the reducer output will be given, right? Now, this is the output given by the reducer, right? This is what we have time. Done, sir. Am I clear? So this is all about you have. Now, can we reduce this time? How? When I'm giving the result on the mapper, How? Which format? Which format, sir? It is giving in this format, right? BJP, BJP 1, right, sir? Just move this. We're giving this result in this BJP 1. Can we directly write this BJP? If I write this, just understand. If I write directly instead of BJP 1 1, if I write directly there, BJP 1 at the mapper output. Anyhow, if I write this mapper output, what the advantage we can have? Anyhow, if I control the output and instead of sending the mapper output 1 1 1, if I write directly BJP this, so let's see what we have the result here. What it will impact on time. T1 is what? Size. So how much size it will take? Byte, KB, right, sir? So let me copy it and now see here. So how much time it will take? T dash 1, right? This byte value will be fetched from the reducer, sorry, task tracker to whom? Reducer. How much time it will take? T1 dash, right, sir? It is very small than T1. Reducer will what? How many times the reducer will call the iterator? Remember that time someone asked me why we are writing a not normal incremental, why we are writing this incremental, because what data it will read? 1 lakh, and it will increment by 1 lakh. That's the reason I was not use the normal incremental get one. So it will call how many times an iterator? Only 1 times. So it will take how much time, sir? T dash 2. So you can see the difference. In comparison T2, T dash 2 will be very less. How many times? 10 like times smaller. And output will be what, sir? T dash. T dash will be very small than T, and of course it will give it the best result. Am I clear? So this is all about job which we have, how to run the combiner exit like this. Now I'm coming on that. This is the objective, right? We want this result. So how to achieve this? For that we write the combiner class. Write down. So what is combiner? Hope you understand. So how to achieve this result? So we can get the best result. We can enhance the performance by the help of combiner. Combiner is what called mini reducer. It reduces the size, right, sir? What BJP is coming in 1 GB, now it reduces the size, right? So combiner is what called mini reducer, and it is optional. It is what? Optional. Combiner is called what? Mini reducer, and it is optional. Means if you wish to use, you introduce. So generally we use in production, the performance part, right? It is called mini reducer, and it will be running on every node. Suppose the data are stored on 4 data node, right? Your input data. So this combiner will be running on every data node. Right, sir? It will be running on every data node, which is completely independent to each other. Combiner can be called one time, so more than one, or it may be not called. It depends completely. We have some fuzzy logic concepts which is being internally you need to work. The framework will be called, right? It can be called more than one times as well. That's not a job developer. Internally, the framework can call multiple times. Okay. It will be running on every node in the cluster. It will be running on every node in the cluster. Right, sir? So this is what we have. The combiner. Let me just be online. So let me go through, right? Okay. So you can see here, this is the combiner we have. Right, sir? The job which you can see, I'm running on every node. Okay. Let me go. This is a job, right? This is all the job. And if you this comes after that mapper output, right? It comes after what? Mapper output. So mapper output, how it looks like? Whenever it finds the similar words, whenever it finds what? Similar words, and we pass to the combiner. You see here, right, sir? Whenever it finds, if you pass the similar words, it will be combined together. Clear? So might be according to our job. On this combiner, BJP will be coming 10 times. Onto this, BJP will be coming 100 times. So it will not rating the combiner BJP1, 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 right? How many times BJP is coming? Similar words, 10 times, 100 times, 200 times, 400 times, right? And you see here, after this combiner, partition will happen. So partition, it will write how? BJP 100, 200, 300 list in that value, and that will be passed to the reducer, and reducer will call 4-time iterator because BJP occurrence is what? 4 times. BJP total record is what? 1 lakh. Clear, sir? So we have to just introduce the combiner in our program and we can get the best result. I see here, if you say here we have to use, I believe you it is right, it is clear now. So this is all about the combiner. Now combiner, why if it is doing the same job what reducer doing, right? Then why we are calling the reducer? Reducer will be taking the complete job of every data node. It is reducing the global data which is coming on to multiple data node, but the combiner is reducing what? Individual data node. Right? So that's the reason we are coming with this. Am I clear? Okay. So now just write down this thing. How it look like the data? Data will look like this. Input, right, sir? The flow will be like this. Input is given to whom? Mapper, right, sir? Mapper. Input will be given to the mapper. And mapper will get the output, right? Mapper output is now what? Passed to whom? Combiner. CO. Now just new entry is there. Combiner. And combiner output will be given to whom? Shuffle. That's simple. What we have for you, shuffle and sorting. Shuffle and sorting and reducer. This output will be given the reducer. The reducer will give the final output. So this is the final flow we have. Okay, guys, are clear now?
So partitioner comes after combiner, right?
So if you want to call to the partitioner, right? If you want to call, combiner, then in the main method, public static one, you have to define the combiner class there. Okay, in the code which we have shared, it's all been there. All right.
So where do we define?
So that's all for today's session. So for more details, you can contact your support team and visit your website. Okay. See you in the next session. Thank you.